Hey everyone, my name is Ethan. We're going to talk about analyzing student interactions with AI assistants using AI assistants. Let's get into it. About me, I live in Tucson, Arizona, former high school teacher, currently doing data and AI things at Nectir, where we're building AI infrastructure for higher educational institutions. Why do we care in the first place? By analyzing the student conversations with their AI assistants, we can learn lots of things. We know learning happens through inquiry, through struggle, constructivism. We can identify the struggle, identify misconceptions, observe students' own awareness of their learning gaps, their metacognition, and ideally, right, create some more dynamic, personalized, just-in-time teaching and support at scale across millions of conversations. Here's our example conversation for this demo. It's a student asking about ATP and the Krebs cycle in a introductory college biology level course to an AI assistant trained on biology documents. So what can the language models extract? Topics, summaries, questions, sentiment, a 1 to 5 quality score for the conversation. Anthropic in their education report early April has this nice 2 by 2 where they label conversations as either direct or collaborative and then problem solving or alpha creation. I'd recommend you give that blog post a read. All right, quick little demo. We're going to take the same conversation I just shared and then this prompt in the student conversation with an AI assistant, what key topics and questions are covered? Now you can do this to Claude or Gemini or ChatGPT. I'm gonna toss it into Nectar AI and hit. So we have the exact prompt here from that slide and then the conversation I shared about the ATP and the Krebs cycle. And we get this response of key topics and questions. Awesome, great. Quick comment on text embedding and clustering. I'd highly recommend you look into this topic. But we can imagine, right, taking conversations for students, embedding them in some space, and then looking at the natural clusters that form. So we can take words and embed them in a space. There's a famous example where we have king and queen, then men and women. And when we do this, we find this nice interaction where they have similar relationships. We see similar things with like Japan and sushi, and in Italy and pasta, where they kind of have similar relationships. On the right here is a plot showing um, various books embedded and the clusters of those books of fiction and nonfiction at the top here. All right, last 2 minutes we have here, we're going to one-shot application. I have on my desktop right here a CSV biology conversations with a conversation ID, the message, and who sent that message. We're going to take a prompt, pass this to an AI coding tool I have. We're then going to read in the CSV, call out to a language model, and get back a summary of the conversation for all 10. So I got a minute and a half. Let's see if we can do this. The prompt is right here. I also have it to my side. And if I go to my coding tool, I'm just going to paste that in there. I'll share this prompt as well. It's going to generate a script. I'm going to apply that. I'm going to run that. I can run it with this command right here. It's going to go through log its results, is reading that CSV file, grouping conversations, etc. Quick time check. Got a minute, yes. We see here the first summary for the first conversation, the second summary for the second conversation about photosenses, etc. It goes down, does this for all 10. This was on enzymes, and it makes this nice markdown file, which we can then preview, which looks like this. So now we have for 10 conversations, a summary of all 10 conversations. You can imagine, right, scaling this up as well. All right, cool. I will stop here. Thanks for your time.